Patrick, hello. Hi. How
Hey,
are
how are we
you?
doing today? Doing
Okay,
well. How are
great.
you?
I'm doing well. I'm doing well. I'm very excited about this talk, Chainlink. I was playing with some Chainlink nodes a couple of weeks ago.
Nice.
Yeah, great stuff, great technology, great documentation. I loved it. Lots of questions around not just the basics, but like the economics and the idea of trust and all that around oracles and all that. So I'm very happy to have you here to be able to hopefully answer some of those questions. But you're going to be talking about how all of this works, what is an oracle, and how we can empower a smart contract with data that's sitting outside of a blockchain. So,
For sure.
yeah, why don't you start with, please tell us a little bit about yourself, what you're doing with Chainlink. I'm assuming you have a slide deck you'd like to share. There's a little icon on the bottom with the up arrow. Yep, that will allow you to share it. There you go. And the stage is yours, please.
Awesome. Yeah. And thanks again so much for having me. Really excited to be here. Let me just make this a little bit wider, or it doesn't really want to go wider. So we're just going to keep it where it is. Really excited to be here and talking to you guys about Chainlink, and especially at DeFiCon and its relation to DeFi, because Chainlink is helping secure something like $10 billion right now in the DeFi ecosystem. So obviously having reliable, secure, decentralized data is a huge point in DeFi and in traditional finance as well, right? Any type of quant firm, any type of financial instrument, they need quality, reliable data to really enact and do anything. So I'm looking at the chat here. Feel free to drop a question. We have less than 20 minutes now, so we will try to go quickly through a lot of stuff, and then we'll leave some time for Q&A here. But yeah, I love having my sessions be a little bit interactive, so please feel free, drop questions. Love answering questions. That's why we're here. So yeah, connect to your smart contracts to off-chain data, financial definitive truth, APIs, and provably random numbers. And why it's everything that we're going to talk about here is so important. So here's a little bit of the agenda. I'm going to kind of skip over it. We're going to talk about oracles first and foremost, and the oracle problem. So in order to really understand Chainlink, we need to first understand that smart contracts are not always able to connect to external data. And by not always, I mean blockchains by nature are deterministic, and they can't connect to external data or any off-chain resource on their own. And this is a huge limiting factor for the adoption of smart contracts, right? So blockchain is great, smart contracts are great, but they're this walled garden, right? They're this walled garden, and they can do token transfers. We can have ERC20s, we can have ERC721s, we can have all these really cool applications, but kind of bridging that gap is difficult because they're deterministic. Now, I know there are a lot of engineers here, and the first question then is, okay, well, why doesn't the blockchain just make an API call? And the really simple answer here is, again, it's a deterministic by nature, right? Blockchains are deterministic. If you had API calls or getting some type of random number as part of the consensus mechanism, one node's going to say, I called the API, it told me it was $200. Another node's going to call the API, go, well, I called it a minute later and it says it's $201. No one's going to be able to match up, and we're never going to be able to reach that consensus, which breaks all of blockchain. So they are deterministic intentionally and on purpose. And so this is why they're kind of these walled gardens and can't access the same normal APIs that we're used to and that power the traditional and current web. So in order to bridge this issue, in order to fix this issue, we need what's called an oracle. So an oracle is any device that interacts with the off-chain world to provide data to smart contracts. They report data on-chain in an external transaction, in their own transaction, so that the blockchain can stay deterministic and they can do that consensus protocol. Oracles are also bidirectional, meaning they can ingest data into the blockchain world, and they can also pull data out of the blockchain world and send post requests and have the real world react based off of what happens in the smart contract world. So oracles are these bi-directional tools. Now, this is great. So we can have an oracle. We can interact with the outside world. Success, problem solved, right? Not quite. So when we're writing our smart contracts are written in this decentralized logic layer, right? All of our smart contracts, they're written by the world's computer. Each one of these nodes executes the computation, syncs up with all the other nodes, says, is that right? 2 + 2 is 4. Okay, cool. Let's move on. If you have this logic layer that's decentralized, but you have your data layer coming from a single node or a single data provider, you're doing all this work to have your logic layer decentralized, but your data layer isn't. Now your application has a single centralized point of failure. And this kind of defeats the purpose of developing a blockchain at all. If you have this single centralized point, if somebody can turn off your data, if you need to trust one provider or one node, then your application is no longer centralized. And in addition, it's less secure. The data isn't going to be as high quality because you're getting it from one single source. So there are a lot of issues with having this single centralized point of failure. So we can get data on chain with an oracle, but we can't necessarily get decentralized data right away. So this is where Chainlink steps in and really is the shining light in this world where we need data on chain to have these smart contracts interact with the real world and be these superior digital agreements. So Chainlink is a modular framework for building decentralized oracle networks. So you can run a single node and basically have it pair up with an entire network of Chainlink nodes, have them connect and get data from the real world and bring it on chain so that your smart contract logic layer stays decentralized and your data layer stays decentralized. So Chainlink is this middleware, this decentralized network of connecting the real world to the blockchain world in a decentralized, honest, trustless manner, which is what we're aiming for when we're doing smart contract applications. And this is where Chainlink really shines, right? So it's able to bring any input from the real world onto the blockchain, and also the reverse, any output from the smart contract world into the real world. So we can do interesting things like we can send in the price of an asset, for example. We can send in the weather. We can send in who the president is, and have our smart contracts, these digitally superior agreements, execute based off of that data. And likewise, in the opposite direction, if there's some type of on-chain interaction, maybe like an insurance payout, maybe even like something as silly as like sending a tweet, oracles provide this functionality as well. So they're this bridge that makes the blockchain world real. So to get you started, especially with DeFi, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet and combined their prowess to build what's called data feeds, or reference contracts. Now, these are decentralized on-chain reference points of truth that we can, consider source of truth because they've already been aggregated in a decentralized manner according to these Chainlink networks. So we can look at an example of what one of these looks like, and these are the data feeds. These are the price feeds that are helping secure protocols like Aave, like Synthetics, and we'll get into a couple more in a second. But you can see here the visualization of literally exactly what it looks like. So we have all these independent nodes, all these little black dots around. These are independent Chainlink oracles that are fetching data from multiple sources, usually reporting that data on chain, and that data is getting aggregated to give a single, already decentralized reference point of truth on the price of an asset. For example, the price of Ethereum and USD. That's what this example is showing. And even more recently, for those of you who've been paying attention, Chainlink OCR just came out, which is a huge upgrade to this system. And it's fantastic because they actually do this aggregation step off-chain, hence the name off-chain reporting, where they each cryptographically sign their answer, and they send just one transaction on chain, which reduces the gas by like 85%. It's a massive upgrade, but conceptually, it's still exactly the same. They're each one of these independent nodes getting data, fetching data. They're aggregating the data into a decentralized reference point of truth, and then smart contract engineers can use this in their smart contract applications. And here's just a couple of key points on the approach to these secure oracles, right? Using these decentralized Sybil-resistant nodes, provably secure, using really high quality data. And obviously the other bit is that it's chain agnostic, right? So right now it's these data feeds are on mainnet Ethereum, they're on Binance Smart Chain, they're on XDAI, they're on Matic. Probably a couple other ones I'm having a hard time keeping track, but more and more, because Chainlink is this blockchain agnostic middleware that's just built to be this supporting middleware for all smart contract applications and platforms. And the reason why, you know, we're stressing a lot of this decentralization so much is, you know, especially when I was putting this presentation together, back in November, and obviously I've made tweaks since then. November, I saw more than 5 attacks in DeFi of over $1 million, right? And these were not, and the thing that crushed me was they were easily avoidable because they were using some type of centralized Oracle or centralized solution that relied on a single point. You know, that one API they were using or that one data source they were using, it went down, or they had like a weird flash loan hack, and that protocol, you know, it loses millions of dollars. So this isn't really something that we want to we take lightly, or anybody else really in this space take lightly, because this is people's livelihoods that you're going to be affecting. So instead, we want to use these decentralized, truly battle-tested, secure data feeds of any kind, right? And again, some of the most popular right now are cryptocurrency assets and pairs, but more and more different types are being brought online. And I'm excited for when there's kind of like a reference point of truth of like what the weather outside for a city is. I think that'll be a lot of fun. But let's look at DeFi right now, right? Because like I said, in DeFi, Chainlink is securing currently something like $10 billion, which is just insane. It just shows how truly battle tested that it really is. These numbers actually might even be outdated. Let's even check out DeFi Pulse right now. Little live presentation here. We'll see some of the top projects in DeFi, again, using these price feeds to stay secure. You know, Aave's here, Synthetics here. Aave with almost 5 billion, Synthetics with 2.5 billion. There's a lot of money that these are protecting in order to in order to keep DeFi moving and keep DeFi secure. So we can head back. So yeah, so some like Set Protocol is using these, Loopring, Aave, Synthetics. There's a massive list of these different protocols, and we can see all the different data.chain. We can see all these different feeds and all the different currently already decentralized aggregators, data.chain.link. You can scroll down. You can see real time. Let's pick one. Let's look at Matic or Polygon USD. Oh, I need to make my screen a little bit bigger. We can see some of the nodes on here that are returning data. And then I think these blue ones are OCR nodes. Is that right? Maybe, I forget. But we can see the different oracles, and we can click into them. We can look. We can see what they look like on market.link, on Etherscan. We can see the contracts on chain and see the interactions that they've had. So everything is completely transparent. So in addition, and then I got to be a little bit quicker so that we have time for Q&A. So these price feeds are obviously massive, right? And they're helping secure, like I said, something like 10 billions right now. More and more data feeds are being added, and it's very clear why Chainlink and decentralized data is so crucial to the entire smart contract ecosystem. Now, another thing that is becoming more and more important as dApps get more and more creative, as we start expanding out and doing more things, is randomness, and randomness in your smart contract applications. Again, for those of you engineers here, I'm a developer advocate for Chainlink Labs. Oh, I guess I didn't introduce myself. I'm a developer advocate for Chainlink Labs. For those of you engineers out there like myself, you know that getting a random number in deterministic systems is basically impossible, but you can always create pseudo-random numbers, right? When you do like, math.rand or whatever your Python JavaScript randomness equivalent is, it reaches for some file or some hash and just grabs that and says, okay, this is the random number, right? And it's not truly random. It does grab the number from somewhere. On blockchains where everything's transparent and deterministic, it makes it even harder to get these truly random numbers. For those of you who are familiar with Ethernaut, the Open Zeppelin platform, they do a fun coin flip game where they say, hey, you have to guess the flip of the heads or tails of a coin that we're going to simulate on chain 10 times in a row. And you're able to do that because the blockchain's deterministic, and you can often guess what the random number is really going to be, because it's not really going to be random. Which obviously, if you have some type of lottery or some type of livelihood on the line, you absolutely can't have a system where the random number is gamed and known. So getting truly verifiably random numbers on chain is really difficult. And we've seen as well, another thing is when a miner actually, well, currently a really common way of getting a random number is you like get the block hash as your random number. Obviously, again, if a miner mines the block with the hash, that would be that would give a random number where they are not the winner. They're just going to keep tossing those blocks out. They're not going to publish them, and now you've basically lost all fairness and all randomness and all true randomness to your application. And you've given these miners a huge edge, which obviously isn't fair at all. And we've seen people try protocols like this and end up getting hacked. So Chainlink VRF is this revolutionary technology where we get a mathematically guaranteed random number, which is something still so insane. My brain has a hard time wrapping my head around it. But there's an on-chain contract that actually checks a seed that you give it and checks with what's called the VRF coordinator, the Chainlink Verifiably Randomness Function Coordinator, and actually checks on-chain whether the number is provably random or not. So you can get this truly random number into your smart contracts, into your application. We're seeing more and more adoption here as well. For example, Pool Together is one that uses it. If you're not familiar, every week they pool interest in these interest-bearing accounts. At the end of the week, they choose a winner to get all the interest. And it's a really fun way to kind of incentivize savings. So really cool. And it says available on testnet today. It's available on mainnet today as well. So really cool. And again, this is just the last bit is the minimum, the smallest thing you can do with Chainlink, or the minimum thing you can do with Chainlink is this any API, is this any data piece, right? Any input and any output. So you can make API calls to these Chainlink nodes and get literally any data you want. And then you can customize your smart contracts to do any type of computation or do any post requests, any get requests, to do literally anything by building what's called external adapters. Now, these are basically just APIs, same as kind of any API that a user has configured. We have a lot of templates for you to be able to just go in, spin whatever you want up, and have your smart contract execute literally anything. We've seen a lot of fun stuff, from sending decentralized tweets to doing some type of to driving to renting out your Tesla, to renting out like an Airbnb, to renting a book from the library, to ordering on Amazon. It's this really powerful feature to customize your Chainlink nodes to be able to do everything. Now, you do obviously, when you're doing it like this, and when you're building these custom systems, you always want to keep the decentrality in mind. So you do want to say, okay, I want this number of nodes to be able to do this as well, so that we can keep it decentralized. So if you don't want to have to worry about building the network yourself, the price feeds and the data feeds are already decentralized for you, which is fantastic. So, and with that, I know that we're going a little bit longer than I wanted to go. For those of you engineers who are like, oh, this sounds really cool. What do I build? What do I want to build? There's this fantastic article called 77 Smart Contract Use Cases Enabled by Chainlink. I'm going to just rip through some of the cool ones, but definitely check this one out. It is just chock filled with ideas. DeFi obviously is huge. There's so many fintech tools that have yet to be built. Fantasy sports, any type of gaming with randomness can be built. Tokenizing your assets. Insurance is one that we're seeing more and more need for, especially in the DeFi space. And just a really easy example is with bad faith insurance. This is having these on the smart contract platform would be a huge bonus to all of us. For example, let's say your crops get all messed up due to the weather, but your insurance provider doesn't want to pay out because of some pre-existing condition or something. A smart contract is going to automatically execute, so they don't get a say in whether or not they want to pay out. And then vice versa, it also protects the insurance provider as well, because doing the right thing is infrastructural when you're using a smart contract and when you're using Chainlink. So really powerful stuff here. And then last but not least, before we get into some demos, I'll do a really quick demo and then we'll do some Q&A. Chainlink Hackathon starts March 15th. We are absolutely amped for this. It's going March 15th to April 11th. And we are doing a ton of demos. Literally the first week we're doing like 10 beginner to pro Solidity smart contracts. So if you have no experience, definitely time to jump in. If you have a ton of experience. Definitely time to jump in because we're working with different frameworks, Truffle, Hardhat, Brownie, all with getting randomness, working with NFTs, building DeFi protocols. Really excited to with the depth and breadth of things that you can build with these Chainlink smart contracts, because again, having this truly decentralized data really allows you to take your smart contracts to the next level and interact and empower your smart contracts to interact with the real world. So if you're an engineer, definitely go check that out. Even if you're not, definitely go check that out. There's a ton of business expertise that's needed at these hackathons that engineers might not have. Maybe you've done tons of years in the medical field and you understand the issues that are there that an engineer just isn't going to have the experience to do, or maybe in some type of business realm or whatever. There's more than just engineers. Artists are needed, engineers are needed, PMs are needed, researchers are needed. So just a great way to get involved, really get networking with some of the brightest people in the space, and then hopefully build something really cool. So definitely check that out. You can go to hack.chain.link or chain.link/hackathon. So I know that I'm running a little bit low on time, so I will do a very quick demo on the price feed. So this is the documentation. Anytime you get lost, you can come to here. If you have no idea what is going on, you can jump into the Discord. There's a link to it down in the bottom of docs.chain.link. And we're always in there. The community is super helpful, always willing to chat and give somebody a hand. But come to the docs, and the easiest place to start is getting this using price feeds, using these data feeds, getting this already pre-decentralized data. Again, if you want to join the hackathon, you can jump in right here. And again, these are so powerful because it allows you to put these into your DeFi applications, with ease. You're going to see how small the code actually is. So for those of you unfamiliar with Remix, you can kind of hit this big deploy with Remix button. You do need MetaMask installed, and you do need, hold on, I think my password is password. Can you guys see that? Oh, you guys can't see my MetaMask. Okay. That's okay though. You can't see my password, but I just popped up MetaMask. Once you hit that link on the side, you'll get these GISts, and you'll just come to the price consumer GIST, the one that we just imported in. It'll import it in automatically. I have a couple here because I've done this a few times, like I said. And this is all the code that it is. It's just this file. So we're importing the Chainlink aggregator V interface so that we can interact with this contract that already pre-aggregates these Chainlink requests. And we take this address, which is right here, and we can see all the different addresses, and then on the different chains that they're on as well. In the documentation, you just grab one off here. We're going to be using the Coven testnet. It's a test network that's Ethereum-like, and we're going to grab this address on Coven, and basically all we're going to do is we're going to call this get latest price function, and all we're going to do is we're going to grab the price, and we're going to see what the latest price of Ethereum in USD is. So we're just going to do a quick compile. Let's deploy injected Web3. So we're going to inject Coven. We're going to be on the Coven network because these nodes do watch specific networks. So this is going to be the Coven network. We're going to hit deploy. You guys can't see it, but MetaMask popped up. Oh, excuse me. I need to switch accounts. 1 second. Now we're going to hit deploy. MetaMask popped up. You guys can't see it. I'm going to hit confirm. We got our little Etherscan link saying it's deploying right now, but it looks like it actually did deploy. And then all we have is this function here, get latest price. We click it, and we can see the latest price of Ethereum in US dollars. For those of you unfamiliar, Solidity doesn't understand decimals very well, so this is actually 1,521. And that is a quick demo. And I know we want a little bit more time for Q&A, but we can take Q&A now. So thank you guys so much.
Yeah, thank you. That was great. I loved it. Great presentation, Patrick. A couple questions. One, typically quality data is centralized, just the economics of it, right? I'm going to pour money into cleaning my data, storing it over years and years and years, maintaining it, and that typically means investments, hundreds of millions of dollars. I'm going to make sure nobody else has access to that data, and so it's a very centralized world. If I want equity prices. I'm going to go to U.S. equities. I'm going to go to the NASD. I'm going to go to the New York Stock Exchange. I'm going to try to go to as close to the data as possible. Can you compare that and contrast that with how would that fit or retrofit in a decentralized world? Because there is this possible implication that the more data providers there are, there are potential issues with the quality of the data. Can you speak a little bit about that and what your thoughts are?
Yeah, 100%. So there's a lot to talk about here. There's a lot, and this would probably be like a half-hour conversation at least. So I came from the traditional. I worked traditional finance world. I worked at a hedge fund for a couple years, and yeah, I get to see kind of the whole inner working. So when it comes to a lot of the equities data, there are a lot of regulations that make it a little bit trickier than some of like crypto prices, for example. Crypto prices is free public data, right? When you exchange 1 ETH for 3 Link or whatever, right? That's going to be on the blockchain. That's public information. Anybody can take that and do as they please. Now with Chainlink, obviously, and the Chainlink price feeds, they're grabbing from these high quality APIs. They're doing aggregations of these different exchanges to try to get themselves the best prices and the most accurate prices. And the reason that they're heavily incentivized to do that is they're getting paid to provide this data, right? And if they start providing poor data, that is going to get recorded on chain forever. So there's a permanent history of each node's reputation and how they've been responding. If a node starts responding very poorly, obviously they're probably going to stop getting jobs. So they're heavily economically incentivized to continue making good and making honest and making strong responses. So obviously with certain pieces of data like weather, where it's very public. Anybody can kind of go outside with a thermometer. Oh, okay, the weather outside is this. It's super easy, and it's really easy to aggregate that data and make it really clean and make it really solid. So these node operators can get paid. For some of the equities data, this is actually super interesting that you even bring that up, because the SEC actually recently released some press about how they wanted to lighten a lot of the restrictions that and power the SIPs have, or the securities information providers have, over the network, right? Because right now, as you stated, NASDAQ, they have a very strict, who can distribute their data and where and how much, and in a public, as you said, in a public blockchain environment. They want to make their cut, right? They're not trying to give out data for free. So it's going to be interesting to see how that world evolves. We are seeing very creative ways to kind of access that data, where it's or access equities data that's not on like the NASDAQ or that's being traded elsewhere, that is public information. But it will be more and more interesting to see how the data landscape evolves, because as you kind of even hit on, data is very quickly becoming one of the most coveted and necessary assets in all systems. And obviously, people want to be, comped appropriately for having high quality data. But we're seeing that in the Chainlink world, there is such a heavy demand. And in the smart contract world, we expect to see more and more demand. And it's only going to make sense for these data providers to get in the game. Otherwise, they're going to miss out.
Fantastic. Thank you for that. That's great explanation. We have a question from Cindy, CEO. Do you have a payment off-chain, on-chain example?
A payment off-chain, on-chain. Like,
I'm going to try to interpret this. I think it's something where the use case is a payment, and then maybe doing a payment and getting some payment, maybe rates information off-chain.
I'm assuming they're trying to pay in like fiat currency.
Let's do like FX information.
Got it. Yep. Yeah. Actually, that's a great question. So again, with Chainlink oracles, you can customize them to do whatever you want. So there are different external adapters. One of them is a PayPal external adapter, where based off the interaction of a smart contract, let's say, I pay 10 Link to, or 10 ETH to a smart contract. Maybe I want it in USD. It kicks off a job off chain that actually sends, it kicks off an API that actually sends money, fiat money from somebody's account to your account. So Yes, basically is the answer there. Again, because of the customization of the Chainlink, like, yeah, you can do pretty much whatever you want. And we have seen demos of people using PayPal as kind of the medium of exchange based off the interaction of a smart contract.
Got it. Fantastic. I think I have a lot more questions, but we don't have any more time. Hopefully we can bring you back in another capacity, Patrick. This is probably a 1 hour thing. Thank you for the time that you've given us. The information that you provided was fantastic. We're probably going to take your slides and distribute it to everybody. We're getting messages requesting the slides. Thank you so much for that. Okay, appreciate it. Great. Thank you.